to what altitude you're at. And it seemed to me both Kelsey and Riley had a boiling point of 93 degrees centigrade. Is that what everybody's been asked? What's the elevation when the boiling point of water is 93 centigrade? Have people gotten other values? Okay. And that's the way these homeworks work. Okay, yes, thank you. I pulled up my chat to see that. All right then. So the basic idea is that I'm going to try the basic idea is you got to find the elevation where the absolute atmospheric pressure at that elevation equals the vapor pressure the vapor pressure for water at that temperature. So we would find the vapor pressure for water at, let's say, 93 degrees centigrade, and then go to the other table and find the elevation that gives that vapor pressure. And I think the challenging part of it is not that, but the interpolation you have to do to get the answer. So I would plan just to do the 93. Let's see, well, I'm going to actually go to the Canvas page, go to student view, and work that problem. Hold on here, that's what I'm doing. All right. Yeah, this one, it keeps giving me 90 degrees. Well, let's just do 90 degrees centigrade first, because then we only have to do the interpolation once. And I'm going to get you all to help me with it. Then we'll take another, we'll have somebody do it, have you do it, give us a temperature. We'll figure out the elevation. You can put it in and see if you get the right answer. How about that? So let's do it for 90 degrees centigrade first. So first, what we've got to do is pull out our textbook, either the digital or I've actually got a hard copy of it. And we're going to go to physical properties of water, SI units. That's table B2. All right, so monitor the chat there, or, oh, I've got it over here, right? So, right, and I think you're still going to have to interpolate the other table to find the elevation. So that's what I thought we'd do it, the simpler version first. And see that we get the right answer, right? Because we're gonna not need to interpolate a vapor pressure, but I believe we are gonna need to interpolate a yeah. Okay. Okay. So well, let's just see that we get the right answer with no interpolation, and then we'll throw one in with interpolation and see what happens. All right. Is that all right? And I think what I've got open now are the participants, so you can. I'm not seeing the chat box, but I am seeing you can give me a thumbs up if that's okay. So that's the plan. Give me a let's get a thumbs up to see if we're okay with the plan. All right, or just speak up, I think, or put it in the chat. There we go. Thanks. We'll do that. So I'm at just show you. I've got my textbook out. I don't know. Maybe I need to turn off the virtual background. You're going to see my. Let's see. Okay, yeah, that's that's where I actually am. All right then. So 90 degrees C is the boiling point. So for 90 degrees C, we go to table B2, go down to 90 degrees C, and look for the vapor pressure. I get 7.01 times 10 to the fourth. So vapor pressure, 7.01 times 10 to the fourth, and that's pascals. Pascals absolute. All right, so with that value, then we go over to the other table, which is table C2, and look in the column for pressure to see what value equals 7. Yes, and you're right, 7.01 times 10 to the fourth is exactly 3,000 meters. So yeah, that's an easy one. All right, so I'm going to put in 3,000. See if I get it right. Correct. Okay. Now I'm going to ask somebody. How about I ask just Ariana? Ariana Brennan. Have I pronounced your name correctly?
Yes.
Okay, Ariana. Could you pull up this question in your homework and let's work it for you? How's that sound?
That's fine.
Okay. Thank you. Thank you for participating on the spot here.
So my value is that it boils at 89 degrees Celsius.
Okay. All right. So we're going to do, and I bet you there are lots of others out there. It boils at 89 degrees Celsius. All right. We do the same process, but now we go back to that first table, table B2, and we have to interpolate between 4.734 and 7.010. So it's 4.734 at 80. It's 7.010, 7.010 at 90. I'm going to do this with Excel. There's probably a fancier way to do this with Excel, but I'm just going to put the numbers in 4.734 and 7.010. And what I want is an equation that's going to be equal. I'm just putting in an interpolation equation, 4.734 plus 9/10. So we're going from 80 to 89 out of the total of 10 degrees. That is the difference between the 90 degree value and the 80 degree value. Pipe up, Zhuang, if I'm doing something wrong. Oh, you would like this a little bigger, I bet. It might be, but did you try this and you got it wrong? Okay, well, let's give this a try. I think the easy thing to try is the first thing to try. So that's the value that we'd say is the, at 89 degrees C, the vapor pressure is 6.7824. Why didn't it go? Okay, 6.7824. 6.7824 times 10 to the fourth. All right, that's our vapor pressure. And now we go look that one up on the same table, 6.2, and looking at the pressures, right? We're going from at 3,000 elevation, it's 7.012, 7.012. And we think that if it's 89 rather than 90, that's probably a slightly higher elevation. So we're looking for something, our 6.7824 is less than 7.012. So we're going to go to the next elevation, was it at 4,000 feet. And that's 6.1666, 6.1666. And so I'm just going to do again with, we're going from 7.012 to 6.1666, and the value we're looking for is 6.782, 6.782. So what we want is, what fraction of the interval is 6.782? And so what we're going to say is form a fraction that is this, the number we're interested in, divided by the entire interval. Again, we're just doing the simple linear interpolation, but back in the other direction. And that says that it's, sorry, 72.7% from one interval to the other. And so that's, we've gone 72% of the way between 3,000 and 4,000. So our answer ought to be 3,000, oops, 3,000 plus this number that we just calculated times the interval in meters between these two values. So that's our answer, 3728, 3728. All right, Ariana, fingers crossed. Yes. Okay, okay. Yes, and it is just me punching away on a Excel spreadsheet here, but let me just add a little. This is the, what's that?
It didn't work.
It didn't work.
I also have the 89% or the 89, and it didn't work for mine either.
Well, Yipes. Because it gets much more complicated if we if we have to go to nonlinear interpolation, because then you need to use multiple points or find an equation. There's, you know, if we were to use something that actually takes into account multiple points, you could plot them and then do some sort of interpolation in Excel. But I think we've gone very far away from you know, what we're trying to learn here. We've done it with a reasonable method. If we get the wrong answer, let's review to see if we got it, that we did it right. Well, the altitude differences are 7.012. Let's and 6. I see the table I'm looking at has altitude of 3,000 versus 4,000 meters. You know, my advisor when I was a PhD student, when something didn't work, she'd always say, "Do it again, do it again." So I think we have to do this problem again to see if to review to be sure that we did it right. Let's back up and go through it. All right, so I'm going to move this number over to there, get it out of the way, to say the 4.734. I'm going back to the table B2. That's at 9. Let's see. 4.7. Yeah, 80 is 4.734. So this is 80 degrees C. And this one is 90 degrees C. Let's confirm that in the table. 4.734, 7.010. Yes. All right. And then let's look at our equation. The temperature we want the vapor pressure PV at 89 degrees C. Right, so we want it to be (9/10), right? You could, I think, get the same value if you said we want it to be this value minus 1/10, right? That's linear interpolation, where you just interpolated it down from the high value instead of up from the low value. All right. And then we're going to go to the other table. That is, we are looking for the altitude where the pressure, the absolute pressure, is that value, 6.782. That's between 3,000 and 4,000. It's 6.166. So there is one extra 6 there. And the way I'm looking, it should be 166. I'd hate to think that that's what did it, but let's get rid of that. And the other one was 7.012. Did we get a different answer? Did we, Ariana, was it still 3728? I don't know. Well,
yeah, it's the same.
I think we should just get rid of this problem. I mean, if people do it right and get the wrong answer, I don't know what the answer, let's look at the solution. Yeah, exactly. And I don't know. I'm going to try. Yeah, right. And I'm going to see if I can go back and do it again. I can't. Let's see. Report. I could report a content error, but let's see. Got any suggestions there, class? I'd say we get rid of it. Well, I think what I would do is I think I would just, but they haven't turned it in yet. What happens if I just modified the assignment to get rid of this problem? That would be my plan. So it would be only 8 questions, not 9. And this question would just go away.
Or can you modify it so you don't take off points after we attempt it again?
I think that'll be harder to give you a, yeah. I mean, I could, because some people are getting it right? Some people actually, it just works out. I can't see their calculation. I can only see the, whether it's right or wrong. So I would, let's see, edit assignment settings. Oh, you know what I could do, I believe I could make this problem have 0 points. Yeah. I think that's what I can do. I'm going to make, that's what I'm going to try to do. It might take me a little bit of doing, but I'm going to try. I think that if Ariana and others did it this way and got the wrong answer, I don't want to penalize them, because this is the way to do it, and we've checked it. We've done it and checked it. So. No, we would never have interpolation. I will not ask you to interpolate on an exam. I have asked questions about this. If you look back through old tests, and I think you'll see that they're qualitative. Give the condition, or explain how you would do it. I don't think I've actually asked for a calculation like this, and I certainly wouldn't have interpolation. So it only is a 50-minute exam. We could spend 50 minutes on just this, huh? One question. Well, I think the answer to that's no, because I think you got lucky. I don't think it was right. Unless, did you do some?
Yeah, that'd be a little unfair, because some people who got 90 degrees, they just had to do 3,000, while others who had to interpolate, that's just 50-50.
Yeah. So, sorry. Nice try. Yeah. And that's an equation that gives you what? Okay, that's an equation for this. Okay, well, I mean, there are more, and maybe, I mean, one of the sections in the text in chapter 1 is standard atmosphere. It is a section that we skipped, but I don't think that's what this is about. Right, there is, right, is that where the standard atmosphere section is? Yeah, and I don't think, it has that plot that shows the, the pressure as a function of elevation, but I don't think that's going to help you either. There it is. Yeah, it's on page 40, page 49. Right. Yeah, you could, that wouldn't possibly give you a different answer. Okay, I'm going to fix it. I'm going to fix it. I'm going to either get rid of the problem entirely, or I think more likely I'll just make it 0 points. All right. So, but you all know how to do it. I guess you're still, I would prefer that you work it as best you can and put in an answer. It'll still tell you whether it's right or wrong, I believe, but then it won't give you any points if you got it right. I think that's how it's going to work, because I do think that this is a reasonable problem. It's the sort of thing you might have to calculate, but they're not giving us credit for doing it right. All right. How about another problem? Any suggestions? Zwing, this is the only problem that people have asked me questions about. Here's a surface tension one. Whoops, and there's the answer. Gotta watch it. Put that student view on. That's not a, I was going to do the quantitative ones. All right. How about this one? Do we, are you, I take it you're still seeing my screen? This one with, this is a compressibility problem.
Dr. Bowen?
Yeah.
Do you mind going through problem 9? After the first part of it, it's more quantitative, and I was a little bit confused about it.
Okay. Okay. All right. And did you get it right on the first part?
Yeah, I got that part right.
Okay. Tell us what's the answer so we can skip
Free body
ahead.
diagram.
You'd think.
Yeah, I'm not sure if you know, but if you miss, like, for the multi-step problems, if you miss the first problem, you lose the entire problem.
Oh, really?
Yes. That's why I couldn't do number 8. Like, if you can't get past the first part of number 8, you can't go to the other steps.
I will, is that part of assignment settings? I'll look into that.
Dan, do you mean for it to take off 20% every time we miss it off of the grade? Like, if we were to get it wrong the first time and then right the second time, it takes off 20%.
Yes, I did mean to do that. And I did that for a reason, so that you wouldn't, so that you'd try to get it right the first time. Because I think that's the way to best work these problems. Is I want to give you credit for trying a second time, but I think it's best to get it right the first time. And I will say that every one of these problems, any individual problem is not very important. There's probably, what are there, 12 assignments. They have, there's like 100 or more points. I mean, 100 or more problems total. So any individual problem is not that important. So, and then 20% of one problem, and you get an opportunity to do extra credit. So I don't think we should get too worked up over what happens on one single problem, but if we think that something's not set up in a way that's helpful, I tried to set it up in a way that I think is helpful to you learning the material. All right, so let's go back then to, I will look into that multi-part. If you get it wrong, the whole question's wrong. I thought that it did it so that it graded them individually. All right. We need a free body diagram. Okay, and so then this was your question? Well, this is one where I could rule out these last three. But Mary Margaret, can you tell me what was your question about part 2?
I got part 2 done as well. It's like a 7-part question. But for part 2, I originally put
7-part question. Wow.
Yeah. So the like first 3 are just
Uh-huh.
qualitative information, and then it gets into the problem.
Okay. So here, right, we've made our free body diagram, and essentially there's the surface tension holding it up and the weight pulling it down. And since it's on top, we haven't learned about buoyancy yet, so I'm hoping that you didn't have to put buoyancy. I would think it's these two. Okay. If we go on from there, right, so I think it is a balance between the surface tension holding it up and the weight that's wanting it to sink. So you'd want some sort of balance between those. All of them look like they might be right because just dimensionally you've got a weight on the left and I say that, but surface tension force, okay, they're calling it surface tension force, and the angle and the surface area. And they give us the angle, right? So what we want then is the surface tension force is acting at a particular angle. We want the component that's vertically upward. So if this is our angle theta, that should be the opposite over adjacent, or the sine. So I would say that and let's see. Yeah, so I would think that it's this. Mary Margaret's that right? I don't want to get it wrong.
Yeah, that's what I got.
Okay. Okay, and this, I believe, something like this is in your, what is the best equation for the surface tension force between the water surface and the blade? Right, we need the surface tension, sigma is force per length. So we want something that's this thing times a length. So there's really only one of those. That's this one in the middle. Yeah. Okay. Well, it's they don't tell you what T is. They don't tell you if this is T. So I think that just the way they worded the problem, if that surface tension force, that indicates it's the total surface tension force acting in that direction. That's why I did it sine theta. if they had, because actually this blade, think of it as a rectangle, and in reality there's a force per unit length. It's acting on the entire circumference of the blade. And so I think that's what, but what they're saying is that T, that total force, is let's see where to go. T is, this total force is surface tension times a length. That would be my explanation of it. Okay. Assemble everything and calculate. Okay, so now we finally put it together. And do they give us values? Where do you? We're working part 5 now, right? Oh, okay, okay. So we have to actually calculate. So we're going to have to get the mass, multiply it times gravity to get the downward force in newtons, the total length of the sides, and then multiply that times the, let's see, the mass of the double H. Oh, and then we're talking double in, all right. So surface, calculate, it wants to calculate the contact angle. So I guess what I would do for this is actually use our equation here for the double edge razor, and that equation for T, and then calculate the angle. Was that where it got difficult for you, Mary Margaret?
Yeah, that makes more sense now. I've never done a surface tension problem before.
Okay. I'd rather not do it and save the time since we're at 105, but
Yeah, I can figure it out.
okay.
I'll go ahead and say I'm at part 6, and part 6, I have no clue what it's asking for.
Okay. Will it let me do part 6 if I get part 5 wrong?
Like, I could just like tell you, like, see how like the answer says theta is equal to? The format it's asking for is sine theta is equal to. And I'm not exactly sure. And I mean, it asks for the single edge razor, but I don't know what kind of answer it is. I don't know what kind of answer.
Well, I'm going to put this in and see what. Let's see.
Don't get it wrong again, otherwise you lose the whole problem.
Oh, you have to get it right. Okay. Okay. Yeah, because we're going to have to. All right. Well, so what is your, and who asked that question? Tell me your name, whoever just said problem 6, part 6 is he. Jake. So let me take a look at this, Jake. I will calculate what the angle is, go on to part 6, and then try to get that part, because it's not showing me. Can you read it to us, Jake, since you're there?
I'll just copy and paste the problem into the chat.
Okay, sounds good. Let's see, I'm gonna.
Oh, and if I were to like try to do in the calculator, I get a domain error. And I'll just go ahead and say that in the hint that it says the correct answer implies an impossibility.
Huh. Oh, that'd be unfortunate. Let's see. Oh, chat. Okay, good. There, I've got my chat up. Now repeat the calculations. Let's see. T is sigma times length, right? Okay, yeah. And I think what it's showing here is if what you get is an impossible situation because for a single edge razor, because it's just too heavy, I believe, or the contact length is too short. You want to enter the answer for sine theta, do not solve. Yeah, it looks like somebody's giving you a suggestion.
Yeah, pretty much what you like find that you need to plug into sine theta to find the answer, you put
Yeah.
that number in.
Okay. But you get sine theta is greater than 1, right?
Yeah.
So, which can't be. There's no value of no value for the angle that'll give you a sine of that angle that's greater than 1. And the reason that is because, yeah, you can't support that razor blade with surface tension. It sinks. Now, but does it give you, is that David who's telling us, does it give you is there a way to get this problem right? Daniel?
Yeah, there is a way to get it right. Let me look at my notes that I took, my work that I did when I did it.
Because right. If you're asked to calculate the sine of theta and you get a value that's greater than 1, you can calculate that. But then when you try to do the inverse sine, it won't give you a...
It'll give you an error in the calculator.
Yeah.
I took that as that shows you that it's not floating.
Yeah.
That's where you your conclusion.
Okay. All right. Okay, well, we've come to the end of this problem session, at least in terms of the available time. I'm happy to keep going, but I'm going to give those who'd like to, feel free to leave the meeting when you want to. And can you see the chat now on my screen? Okay. Interesting.
That's why I brought up the 20% thing, because there's like 7 parts to each one, and it's like they're pretty hard questions. So.
Yeah.
For that one, I had the surface tension times length times sine theta is equal to mass times gravity. And when you go through and solve and do the sine inverse, it gives you your angle.
Correct. Okay. Thank you. All right. I think we finished this problem. I'm prepared to go on. Are there others that these last two are trouble? Are there others that are... This is a viscosity problem, I believe, is problem 6. Eight and 9. Okay. Well, if there aren't other questions, then I'd say let's call it a day. Anybody else want to bring up a question? Remember, you can ask questions on the discussion page, and you can come back at the office hours at 5. Remind me, Zhuing, when your office hours are? Okay. Okay. They will, yeah. Thanks for the reminder there, Victor. I am going to give myself a note to change those due dates. And prob 8 goes to 0 points. Okay, that's it from me. We'll see you, and see some of you on Monday. Have a good weekend, all. I'm gonna stop the share and say.